Hi students, welcome back to the online lecture series of Basics of Computer Network. Guys, we have made this video in two subparts, that is 4.3, 4.1 and 4.2. But before starting our today's topic, moving towards today's topic, let's have a quick revision what we have studied in our previous lecture. In our previous lecture, we have studied about the controlled access techniques, reservation. In reservation, those stations want to send the data. They want to make a reservations before transmitting the data. And second method, we have seen about polling method in that select function, in that polling function, how they are going to use in order to send the frame, in order to avoid the collision. After that one, third method we have seen about the token ring. A special type of packet which is called a token, which gives authority, right, to the station. And after possession of that token, they can send the data. And the token, it is received by the, getting by the predecessor. And after finishing the transmission, the current station, it is going to move past the token to its successor. So let's have a discussion with our today's topic, that is channelization. Channelization, or sometimes it is also called as a channel partition, in which the bandwidth of a link of a medium, it is shared in terms of your frequency, time or code among different stations. So there are three types of channelization methods are there. First is FDMA, that is frequency division multiple access. Second is your time division multiple access. And third, it is your CDMA, that is code division multiple access. So let's start with our discussion. FDMA, that is frequency division multiple access. So in FDMA, the available bandwidth is divided into number of frequency bands. You can see it. This is the frequency bands which is shown in a different color. This is the overall bandwidth. And that bandwidth, it is divided into number of bands, and each station, it is allocated a band to send its data. You can see that station 1, it has a particular frequency band which is shown in blue color. Station 2, it has a different frequency band shown in yellow color. Similarly, station 3 and station 4. Or in other words, we can say, guys, that each band, it is reserved for a specific station. It belongs to that station all the time. And each station, you know, they are going to use that band pass filter to confine that transmitter frequency. Now we can see this figure. Station 1, since it has allocated a frequency band, station 2, station 3, and then station 4. So you can see from the figure that the stream of data, the continuous flow of data, it is flowing through a particular band. It is transmitting through a particular band for the entire duration. And this FDMA basically we use in a cellular telephone system. Although, guys, you were thinking that FDMA and FDM conceptually they seem similar, but there are differences between them. Because you understood this diagram, it is very simple. But I want to emphasize on the difference between your FDM and FDMA. Basically, remember guys, FDM, it is a physical layer technique. It is just going to combine, the data, the load from low bandwidth channels and transmit them by using a high bandwidth channel. And those channels are combined, they are low pass. And multiplexer, it is going to modulate the signals, combine them, and then it is going to create a band pass signal. And the bandwidth of each channel is shifted by multiplexer that we already seen in our previous lectures. But whereas FDMA, guys, on the other hand, it is an access method in the data link layer. FDM, it is a physical layer technique, whereas FDMA, it is what? Data link layer technique. The data link layer in each station unit is going to tell its physical layer to make a band pass signal from the data passed to it. And the signal, it must be created in this allocated band only. There is no physical multiplexer at the physical layer. So the signal created at each stations are automatically band pass filtered. They are mixed when they are sent to a common channel. See, the data from station 1, 2, 3 and 4, they are combined together. They are mixed and then they have transmitted over this common channel. So it's all about your FDMA. As I already told, the bandwidth of the channel is divided into bands, but they are separated by these guard bands. You can see, guys, a difference between these frequency bands, which is called as guard bands, so that the data from each band should not interfere with each other. Now next, we are going to see, it is your time division multiple access. Now, in TDMA, the stations, they are going to share the bandwidth of the channel in time. Each station is allocated a time slot. See, this is a frequency and this is a time. So each station, it has allocated a particular time slot during which it can send the data. Station 1, it has first time slot. Station 2, it has a second time slot. So one by one serially they need to send the data. But what is the main problem with TDMA? It is achieving a synchronization between different stations. Because each station, guys, should know what is, the beginning of its slot and the location of its slot. And due to which, because of the, the propagation delay which is introduced in the system, if these stations, they are located at they are spread over a large area. So due for this compensation, we need to introduce this guard time as we introduce in guard band. For FDMA, we need to introduce guard time in your TDMA. So that the synchronization, it could be easily achieved. That what is the beginning of the each slot. And bandwidth, you can see from the figure that in TDMA, bandwidth it is just a one channel. That is time shared between different stations. Bandwidth it is same, but duration of utilizing that band it is different. Again, there is conceptually TDMA and TDM seem similar, but there are differences between them. Again, TDM, it is a physical layer technique that is going to combine the data from slower channels and transmit them by using a faster channel. And this process, it uses what? Physical multiplexer. Whereas TDMA, it is an access method in what? Data link layer. The data link layer in each station tell its physical layer to use the allocated time slot. There is no physical multiplexer at the physical layer. This is the difference between your TDMA and TDM. Now, starting with our CDMA, that is a code division multiple access. So you can see on the screen that only one channel it is going to carry all the transmission simultaneously. And CDMA, it differs from FDMA in that only one channel occupies the entire bandwidth of the link. In FDMA, bandwidth it is allocated as a slot, different slot it has been made. And CDMA differs from TDMA in that all station can send the data simultaneously. There is no timing sharing. As like in TDMA we share the time. Now you can easily get the clear idea about a CDMA by using one analogy. That suppose in a large room, many people are there. And in that room, two people, they are talking, privately in English. Whereas other people over there, they don't understand English. Only that two people can chat with each other in English. Whereas another two people, they can talk in Chinese only. And rest, they couldn't understand the Chinese. And similarly, rest, another two people, they are talking in German. Whereas no other people, they can understand German. So, I mean to say that common channel it is there. The space for the room in this case, it is a common channel. But the communication between several couples, they are in the form of your codes in the different languages, so that the another couple wouldn't understand the language of a first couple, and so on. You can get the clear idea from this figure. Now let us assume, guys, we have 4 stations. Station 1, Station 2, Station 3 and Station 4. They are connected to this common channel, same channel. And the data from Station 1 are denoted by D1. From Station 2 it is D2. Data from Station 3 it is a D3. And data from Station 4 it is a D4. Then we are going to assign the code. This is called a chip sequence, code sequence. And this code sequence, it has been allocated differently to each station. So C1 is not equal to C2, not equal to C3, not equal to C4. All the stations, they have a unique code word. And that we are going to multiply each code by the data at each station. And then we are going to adding those data like D1 into C1 plus D2 into C2 plus D3 into C3 plus D4 into C4. And this data that go on the channel are the sum of all these terms. And remember, guys, any station that want to receive the data from one of other 3, multiplies the data on the channel by the code of the sender. We can see the example right now. We will see the example. That suppose stations 1 and 2 are talking to each other, and stations 2 wants to hear what station 1 it is transmitting, saying. It is going to multiply the data on the channel by C1. It means this data, this common data, it is multiplied by what? C1. Why C1? Because this station wants to listen what this station 1 it is going to transmit. So CDMA, it is based on what? Coding theory. Each station, it is assigned a code which is nothing but your sequence of numbers, which is called what? Chips. Now let us see the details about those chips. Now these are the four chip sequences, as we have seen the four stations. So there are four codes: C1, C2, C3 and C4, and each code, it is multiple of this chip sequences, and each sequence, it is made up of n elements, where n, it is a number of stations, and over here n is 4. So hence there are 4 elements are there: 1, 2, 3 and 4. So in each code there is a chip sequence, and each chip sequence, it is made up of n elements, that is 4 elements. And what is n? It is a number of stations. Second, if we multiply the two equal, if we multiply a sequence by a number, every element in the sequence is multiplied by that element, which is called a multiplication of a sequence by a scalar. So for example, this is a chip sequence we have taken, and we are going to multiply it by 2. Then what would be the resultant? That is a 2 into plus 1 plus 2, 2 into plus 1 plus 2, 2 into minus 1, that is minus 2, and 2 into minus 1, it is a minus 2. Now, if we multiply, third property, if we multiply two equal sequences, element by element, and add the results, we get n, where n, it is a number of elements in each sequence, that is a number of stations, which is called what? Inner product of these two equal sequences. So you can see it over here. This is two equal sequences are there, 1 and 2. So we are going to do the multiplication element by element, that is plus 1 into plus 1 over here, plus 1, plus 1 into plus 1, it is plus 1, minus 1 into minus 1, it is a plus 1, and minus 1 into minus 1, it is a plus 1. So the adding the resultant, we would get 4. 4, it is nothing but your number of elements in each sequence, which represent number of stations. Now, fourth property, if we multiply two different sequences, that is element by element, and then we are going to add the result, we would get 0. And it is called the inner product of two different sequences. So let's have an example for this. See, there are two different sequences are there. And element by element, if you are going to do the multiplication and you are going to do the addition, you would get 0. Plus 1 into plus 1, plus 1, then plus 1, minus 1 into plus 1, minus 1, and minus 1 into plus 1, minus 1. Adding these, you would get 0. And last, fifth property. Adding two sequences means adding the corresponding elements, and the result is another sequence. So you can see it over here. We are going to add these two different sequence, element by its corresponding element. Plus 1 over here, plus 2, plus 1 plus 2, minus 1 plus 1, it is a 0, minus 1 plus 1, it is a 0. So it is a new another sequence, it has been formed. Now, data representation. We are going to follow some rules for encoding. And please remember this, guys, because in previous for the part, we are going to utilize this encoding. So please remember this. If a station needs to send a 0 bit, this is a 0 bit, it would be encoded as what? -1. If data bit is a 1, then it is encoded as what? +1. And when a station, it is idle, it doesn't have any data to send, no signal, then it is interpreted as what? 0. Understood? 0 is encoded as -1, 1 is encoded as a +1 and silence, no data, it is represented as 0. Now, as in this figure you can see there are 4 stations are there, and 4 stations they are going to use the link during 1-bit interval. We assume that station 1 and station 2 they are going to sending a bit 0, and as we know bit 0 is encoded as a -1. It is a -1. Similarly, station 3 it is silent, it means it has no data to send. And similarly, station 4 it is sending a bit 1, so it is interpreted, it is encoded as a +1. And these are the the code sequence that has been given a unique code to each station. You can see it. Code C1, it has been given to a station 1 which is +1, +1, +1, +1. 4 elements are there, 4 stations are there. Similarly, this is a code 2, C2, assigned to station 2, that is +1, -1, +1, -1. Code C3, it is +1, +1, -1, -1 assigned to station 3. And this is a code +1, -1, -1, +1. It has been assigned to station 4. Now, the output of the station 1, it is what? It is multiplying your data by this code. So -1 it is multiplied by +1, that is a -1. Similarly, -1 is multiplied by this +1, it is a -1, -1, -1. So this is the resultant data from the station 1, that is -1, -1, -1, -1. That is D1 into C1. Similarly, station 2 it is going to perform the multiplication, that is a D2 into C2, and over here D2 is -1. So -1 into +1 it is a -1. -1 into -1 it is a +1, -1 into +1 it is again -1, and -1 into -1 it is a +1. So it is a resultant of your station 2. Similarly, we are going to multiply the data with code C3, but over here silent it is there, no? So it is encoded as a 0, so 0 into all bits. So you would get a 0 over here, that's a D3 into C3. And similarly over here, this is multiplication D4 into C4, that is a +1, +1, over here it is a +1, +1 into -1, -1, +1 into -1, -1, and +1 into +1, it is a +1. Now on a common channel, these all the data are going to be added by its corresponding elements only. That is first row, first column, it is being added with each station, that is -1 plus -1, that is a -2, then -2 plus 1 it is a -1, and -1 plus 0 it is what? -1. So we are going to write -1 over here. Similarly, this is second column, that is -1 plus 1, that is a 0, 0 minus 1 it is -1, and -1 and 0 it is what? -1. So it is what? -1. Now similarly, third column, -1 added with the third column from station 2, that is -1, -2, -2 minus 1 it is a -3, and -3, 0 it is -3. So it is written as -3. Similarly, this is -1 plus 1, that is a 0, 0 plus 1 it is a +1, and +1 plus 0 it is what? +1. So over here it is a +1. 1. So this is the data which is going to be transmitted. So understood, guys? And suppose any station wants to receive the data. If station 3 wants to listen to station 2, then it needs to multiply this common data by means of what? C2. That is your C2. It is your C2. When this station 3 wants to listen to station 2. Okay. So up till now it is fine over with this topic. In next sub part, the second video of this module, we are going to discuss the details of these CDMA. So stay tuned to video 3.4.2. Till then, thank you very much.